Hello, everybody. Welcome to our proMX webinars. Hopefully, everybody were able to join us. I see already there are so many people joining us today. That's super nice. We will start already. My name is Elena Yaruchik. I'm a CMO in proMX, and today we have a very nice session. Which will be related to project operations and scheduling API together with Daniel Bach. Cannot see you, Daniel, yet, but hopefully you will join us in a second. Yeah, hi. Daniel is head of R&D in proMX, and he will tell us a bit more all these functions. I saw his presentations; it's brilliant. It's very long, but hopefully it will be very interesting for you. Just a small thing from my side. As usual, please subscribe to our newsletter to get the latest updates and all the information about the webinars. Upcoming webinars, as you know, we are doing them, at least trying to do them each 2 months. The next one will be in May regarding Dynamics 365 marketing tools. So please also join us. Also find all the important information in our social media, subscribe on them, and there are everything that we have: new white papers, videos, new sessions, and everything. So the other small thing is regarding the questions. Daniel will share his screen, so he will not be able to see your questions during the session. But of course, in the end, he will be able to read them, to answer questions. We planned that time. So please feel free to put your questions during the session in the chat. And then, we will answer, of course, them. So Daniel, your turn. Please let us start.
Stop the screen share.
Yeah, I will stop sharing my screen.
Is the screen visible?
Not yet.
Maybe I need to turn off the video first.
Yeah, now I see your screen. Yeah, super.
Okay. Hello and welcome, everybody. Today in this session, I want to give a basic overview of the project scheduling service, the scheduling engine we need to use in project operations. First of all, my name is Daniel Bach. I'm the head of research and development at proMX. And I'm working in the business for 11 years right now, and I'm also part of the project operations, alias project service automation journey since day one. And today I want to give some insights on the scheduling API. Here's the basic overview. First, we start with a basic overview of what is project operations, what it is built on. Then I introduce the so-called scheduling entities and mainly why it's important to use the PSS API if we want to work with the so-called WBS elements. At the end, some tips on the error logging, how to work with errors, how to find them, how to solve them. And at the very basic end, I give an overview of basic common issues you should be aware of when writing low code addressing the API. And then we have a Q&A session at the end. And I will also show some prepared cloud flows where I use the schedule API. First, in the beginning, project operations is not a brand new product. Previously, it was known as project service automation, and project operations now is the latest version. And as we can see on the right-hand side, project operations is based on project for the web. This is the WBS, so the task grid view we are using in project operations. We have the basic elements like entities, sales integration of project service automation. And finally, we also have finance and operations in the background. There you need to know there are different deployments using project operations. The easiest one is the so-called project operations light deployment. With the light deployment, we are only using the customer engagement and do not have any finance and operations in the background. Then we can also use the integrated scenario. where we also have finance and operations in the background, where we can do advanced features like subcontractor management and so on. And all together, as we see, is the project operations. Okay, coming to the overview of what are scheduled entities. On the right-hand side, we see a short list. On the left, we have the WBS structure, where we can see it is in the Gantt view. So under scheduling entity, we understand everything in regards to the WBS, or the work breakdown structure, like the project tasks, the project team members, we have resource assignments, and we have the project task dependencies. All these are called scheduling entities. Now with project operations, as we saw in the previous slide, while it is based on the project for the web, the access to these scheduling entities is restricted. Why is it like this? Microsoft is using project for the web. This is a service, you can call it IP from Microsoft, from the project team. So it's not maintained by the project operations team. Therefore, you do not have direct access to the Dataverse entities, so you cannot write a flow, use a workflow, or write a plugin, creating project tasks, resource assignments, and schedule them on your own. This is not possible. This is restricted by the system and also blocked. So when you try to create project tasks via any call or using any flow, the system is blocking to create these entities. Right now, also Microsoft is working on other functionalities where you can bring your own scheduling, but this is not existing at the moment. And as I mentioned, therefore, we have limited access to these entities. And for this, we need to use the PSS API to use them. Also, as an easy addition, in a previous session, we were introducing how we can bring back a copy project functionality to implement template management. This is also an easy functionality where you can use creating copies without using any API. This is a simple action you can call in the system to create copies out of your existing projects. And then just imagine like you have predefined projects and you can reuse them anytime, or just reuse an existing finished project in this case. Okay, here we see the list overviews, as I mentioned, of the scheduling entities. And on the right-hand side, we also have the overview of possible operations when we use the API. So we see create is possible for all the entities, also the updates, and we can see delete might be difficult, but this we will see later in the details. This is a screen coming from the Microsoft documentation, and when you have a look to the slides later on, I'll also put the links inside, so you can review the SDK documents from Microsoft as well. In the system, it is very easy. It is a set containing custom actions. So you can call them with the flow integrations, or you can also call them by code when using JavaScript or also using plugin. So when you are a developer, you can also use the same exact actions I'm using here in my samples. Also, as mentioned, we need these operations to have the create, update, delete operations possible on these scheduling entities. And for the API itself, we need to think about every call we are doing is stacked in a so-called operation set. And the operation set is executed at the end, asynchronous in the background of the PSS. And the result is written back to the Dataverse. So we can easily say it's a batch run. Later, I will also show how the API is called and how it will run through the different stages. Here it is important to know the API limits. So per user, so system user, we have a maximum of 10 open operation sets possible. Open means is an operation set is open until I call the execute operation set action. So at the moment, I create the operation set and then I start to stack operations in it. The status is named as open, and with the open status, I can have maximum 10 operation sets per user. Then it's important to know that inside the operation set, we can have a maximum of 100 operations. Just keep in mind the limitation of the WBS, where you can have a maximum of, let's say, 500 tasks easy do the calculations. So for creating 500 tasks, you would need 5 operation sets. There's a small difference. We will see this later. This is for the project and the project team member. For them, we have our own action call, and we do not need an operation set for this. You will see the basic flow, how to maintain and use the API. In the first stage, turn on the laser pointer. We'll start here in the upper left corner. First, we create the operation set. We bring in operations we want to execute. This data is validated before we give it to the service. We see it here in this case. We call it is some sort of metadata validation. It will validate if the fields you are calling is valid, if the value is valid. Just imagine like creating a project task, the end date cannot be before the start date, or you do not have a negative duration, something like this. This will be validated in this meta validation. So in this stage, when you have an error, you get immediately the error code from the API, and that will not continue. Later, when you have everything in the operation set stacked and you execute it, it will be passed to the service. Then it also performs integration checks and validation. But at this point, we are in the PSS, so the service itself, and this is an asynchronous operation. So at that moment, the system will create a log file, and when an error handles, it will roll back the complete operation and also write the log files. So you need to handle the runtime of the async operation, and then later on refer to the log files if the operation was successful or was cancelled. Here we have it in an easier flow, what you need to maintain. As we can see in step 1, we start by creating the operation set. This will also initiate the log of the entry in the system. In the second step, we add all our different calls like create, update, delete operations to the operation set. Keep in mind the maximum of 100, so every operation is counting to this. So let's say we create 2 tasks, 2 operations, we link the tasks, 3 operations, we assign resources to them, 6 operations, and so on and so forth. Also important to note is there's a restricted field list. I will also present the links later so you can refer to these. It is not possible to address every system field via create or update operations. It's also possible to use custom attributes and the out-of-the-box fields. So when you enrich the project task or maybe the project entity by new custom fields, you can also use them in the API calls. So you do not need to have a splitted handling of API calls in the out-of-the-box functionality of project operations and your own. Simply use them with the API together. The third step, as I mentioned, the basic metadata validation is performed together with integration checks, and the user gets direct feedback because at this stage we are in the synchronous execution. So when you perform an error in this stage, you get immediately response. For this later, I will also show why it is important to use the abandon operation next to the execute operation. In the fourth step, when we do not have an error, we simply start by processing this request and push it through the API. Step 5, just as mentioned, is the acceptance of this operation set. So the basic metadata validation was performed, everything looks good. So we pass it over to the PSS, and now it accepts the operation set and all the operations inside and starts with the asynchronous processing. Step 6, we see it will execute what is inside the operation set as a transaction. So in any case of error, it will completely roll back the full transaction and write an error code to a log file you can refer to. And when the operation was completed without any error, the data will be written back to the CDS and the related entities like project task, resource assignment, and so on. Last step, also as mentioned, we have the error log we can refer to. And it's also good to know, as I mentioned, you only have a maximum of 10 open operation sets. So when you do not execute them or abandon them, after a certain amount of time, they will automatically be canceled by the system. In the previous versions of the API, it was important that you keep an eye on the operation sets and if they are closed and removed by the system. But this we will see at the end later. Okay, now we will start with the big theory part. In the next following slides, I have the layout like this. On the upper left corner, you will see the action name you need to call. So this would be the Innostone Create Project V1. This is the first action introduced to you to create a project in project operations. Now you might wonder why we simply do not create them using a create operation in the flow, and why do we call the API? The answer is very simple. When you create a project in the flow with a direct create without using the API, the system will not create the so-called default bucket for this project. So at this point in time, you simply have an empty project record without a bucket. And in the next stages, we will also see it's important when you create a project task, you need to assign them to a bucket, and this operation would fail. So do not create the projects directly in the flow, simply use the API. Otherwise, you would need to trigger the WBS view to get the default bucket first. Also, as I mentioned before, for the create project, it's an immediate operation. And for this, we do not need to open and execute an operation set. As I mentioned, we can use the default fields of project operations, and we can also use our custom fields. Also, as a reference is the full list of restricted fields. And on the right-hand side, we have an overview of the fields we can use in the create, like the contract line project, the organizational unit, and also something like the finish date. And with others, I'm just mentioning like all the other fields may not be usable with the API, but this is something you need to try on your own, experiment a little bit. The documents are not up to date right now. Okay, now I start with the first sample. The left-hand side, I have an overview how the call would look like in the flow, and on the right-hand side, I try to give an overview how the formula would look like in the JSON format. So basically, we can see we start by calling in the action via unbound action in the flow. And with the trim function, it's a valid operation to remove all the fields from the action and give these so-called action parameters where you can type in your JSON files by hand. And on the right-hand side, as I mentioned, you can see this is the action schema name. This is the reference you need to use when you want to call the action. Then following from a small JSON file, you see we have the schema name of the attribute. In this case, we have the subject, so the project name. We have the description, and here's the reference customer. For the customer, it's important to note the customer is a lookup field. So lookup references you need to write like this. And then next to it, you need the schema name of the entity in the plural format. I just highlighted them in red that you can see the overview. We have the organizational unit. You see this is a lookup reference. We have the project manager, it's a system user. And we also have the currency. And last but not least, here's a small example where you see I have a custom attribute in the environment, and this is an option set. And the option set I set to false, so it's a simple Boolean variable, nothing special. And also for the dates, as you can see, the basic sample, I just used the function to use the current date and time as schedule start date. Next operation possible is the create of project team members. As you know, when we create the project in the first place, we automatically get the first project team member based on the project manager. So the user who is the project manager creating the project will also be created automatically as a project team member with the role defined in the project operations parameters, who is the project manager. Also, as mentioned, this is an immediate operation, and you also do not need to use the operation set. So you can simply call it and the team member is there. Here we have a very basic sample how this looks like. As you can see, the JSON is a little bit different to the one before. And here I also need to highlight, we will see this later in the common issues tab. When writing this file, must be very careful for this one. This defines the related entity type you want to create. In this case, we want to create the project team member. This is the schema name. And the data is written like this. Why I marked this in yellow, I will show later in detail on the next slides. Then again, we have different kind of lookups. So we see we have the project, and we also have the role of the team member. Of course, we have a name. And important, when we create the data, we can define a GUID what should be set. This is important. I would say at the beginning, create a JSON variable and simply store the GUID values. It is easier to reference the GUIDs when you have it saved in a variable. Otherwise, you would need to pass through the data again to get it. Just imagine we have an operation set, we put in create 100 tasks. And when you do not save the GUIDs in the background, you cannot link the tasks because the data is not created yet, so it is not existing. So simply keep in mind creating the GUID, save it at the place like a variable, and reuse it when you want to link records and add additional elements later. Okay, now we come to the part of the operation set itself. This one is very basic. We have a create operation set. On the right-hand side, again, you can see how it is written with the JSON format. As we see, it only contains 2 parameters. So it's not required that you write it like this. For the create operation set, you can simply direct use the unbound action in the Microsoft Flow. It's important to note that the description is a required field, while it's not marked as required in the action itself. So just keep in mind, description is required, so write in what behavior the operation you want to perform should have in this place. And again, as I mentioned, keep in mind the limitations, 10 operation sets in open state per user and 100 operations per operation set. Then the next one is the execute of the operation set. When you created the operation set and you stacked all the operations in it, at the end, you need to execute it. At this point, it will be handed over to the API and processed in the background. The result then is written back to the Dataverse. And on the right-hand side, as you can see, we can also directly call them with the flow unbound action. But if you like, you can also use the trim operator and write the actions parameter in JSON format. Last but not least, a very important step is the abandon operation set activity. This just is required if you do not want to execute, you simply want to cancel the operation set, call this action and it will cancel the operation for you. This is important in case of metadata errors handling when you add elements to the operation set. Just as mentioned, I have a create task operation with a negative duration. In this case, I would get a direct exception when I add this call to the operation set. So when you would execute this operation set, of course, you would receive an exception. So in this case, you can handle error handling to your Cloudflow and simply abandon this operation. This is important when you write a lot of API calls and use a lot of operation sets with your user, because you have the limitation of 10 open operation sets. So an abandoned operation set is not counted in this maximum limit of 10. So simply cancel it. And we can see it's very basic. It just uses the operation set ID from the create operation set action. So you do not need to write it with the trim operator. Okay, as I already said in the beginning, the operation is performed in the background of the PSS and the result is written back to the Dataverse. It is highly possible that this operation takes some time. Just imagine I have a maximum of 100 operations per operation set. So I put 100 operations in this operation set and I let it execute by the API. It is not created within 3 milliseconds, something like this. So just imagine you create your first operation set creating tasks, and then you have a second operation set linking these tasks. You can only execute this second operation set when the first one is completed. Makes totally sense. So therefore, we can use the get project save status. This one returns the value if there's still an open operation running on the project. And then you can see in the in the right-hand side, it's a simple loop up to the point when the save operation is completed. So then I can jump over and call other operation sets. So this is important to ensure that the operation you are performing was completed by the system. Now we come to a mixture of different API calls. We can group them on the PSS create, PSS update, and PSS delete. And as we see on the table on the right-hand side, they are used to work with project buckets, project tasks, project task dependencies, and the resource assignments. For all of these entities, we are used the exact same action call to perform all our operations. And the samples I will display on the next slides. Also very nice and new handy API call is the handling of project buckets right now, as we can see on the table on the right side. This is possible since update release version 16. Previously, it was not possible to create or update or delete project buckets. So you simply had the default project bucket in place and you could not use more of these. But this is now possible with the API calls. And again, the API calls, you see it on the top left. These are the schema names you need to use in the trim function when you call the action in the unbound action with your Microsoft Flow. Okay, as I mentioned, let's start first with the project bucket. So we have the PSS create v1 call. And on the left-hand side, we see in this case, it's important to know. Again, we are creating an entity. So we need to define schema name of the entity. It's the MS bucket. This is the way how to write it. And then we simply have attributes for the bucket name. The bucket needs to be linked to a project. For this here is the binding. Keep in mind again the schema name in plural format of the entity reference. And as mentioned again, we create a grid, and this one is used for the creation of the new bucket. Also important, never forget to use the originally created operation set ID, otherwise you also get an error. So with this, we stack the create operation for a new project bucket to our operation set. And also very important to highlight, maybe put this to red, just noted for you. A very common mistake is this one. Keep in mind the data on the right-hand side is the correct one. So you need to use to @ when you give the entity schema name. The problem in the Microsoft Flow is you will recognize it when you use it. At a certain point in time, when you have any update operation, Microsoft will kick out one of these and you get an error message. So you cannot save your flow anymore and the flow cannot be executed anymore. So in this case, simply scroll over all your JSON documents and check for this small issue here in this place. This was one click too much. Okay, next one is the project task. So right now, imagine we created a project, we created a bucket, and now we want to create a new project task and assign it to the project and the bucket. Again, we can see we have the same structure. Just note down, there is no fixed format, so you can put the entity schema name at any place. It must not be in the first position. So put it anywhere. Just keep in mind to use 2 of those. And again, use the references for the entity links. Important here, this case to note is we have the metadata validation, as I said. So when you put in a start date and an end date, there is a validation. So in this case, I simply create the project task with the start date and I give them an effort and a duration. So the end date of the task will automatically be set by the API. And also, you see it, we have the outline level. It's also possible to create the project task in a hierarchy. So we have a parent task and a child task. When we have a child task, you need to add an handling for the outline level. In this case, I simply create a task in a very basic overview. And I will demonstrate this later in the flow when I present my sample files. And also note, as mentioned, again, we have the project task ID, and here you can see I'm using variables in the system. So I put the GUID also as a subject and a node to the project task that I can directly see what data was used in the system. Then the next operation is the linking of project tasks so that we can see a very nice dependency in the Gantt view. For this, we use the project task dependency as schema reference. So again, we see it here. Again, keep in mind to use this format, use the schema name to create a project task dependency. Here we see from the previous sample, I have created 2 tasks. Now I start to simply link them together. Again, we have the reference to the related project. This is our lookup. And we also set a GUID to the file and the link type. This is the default value. You cannot change. Now on the right-hand side, it's important. I also marked it in red. I hope you can see it. When writing the JSON data together, it's important to keep in mind that in a certain time it's important. The schema names are case dependent, not independent. So you need to think about how to write it. You see it. The entity reference of the project is starting with a capital P. Similar predecessor task, P and T is capital, and for successor task, it's the same. Later in common issues, I will come back to this point and note how to identify these errors very quick. Last but not least, we have our resource assignment we want to create. Again, and as always, we are calling our type of the entity. We use the schema name for the related entity. In this case, it's our resource assignment, and we simply create it. With the resource assignment right now, it's important to note that you cannot change the contour files right now of the assignment. So the estimated effort for this project task will be distributed into the resource assignment based on start and end dates. So when I have 16 hours for 2 days, you get eight each. Just keep in mind, this is an operation Microsoft announced to implement soon, but it's not existing right now. Okay, let's come back to the point of errors. As mentioned, the system, when we create the operation set, it will stack the operation calls in it. This is an entity record in the system, and you will find it in the settings area of your Dynamics navigation. And also the operation set, just remember back in the create operation action, you call it with a project as a reference. So the operation set is also directly linked to the project. And later, when there is an error reported back by the PSS, it will create a so-called PSS error log attached to the operation set. So with this, out of the project, you can directly refer to the operation set and the PSS error log. You also see a small screen on the right-hand side, just as a basic overview. This is also important when you want Microsoft support. Just also mention the system URL, system ID, and tenant ID together with a timestamp, because the system will write a so-called session ID and correlation ID to the error log. The same is for the operation set. And with these correlation and session IDs, the Microsoft support is able to check the PSS, so the backend, what was going wrong. In some cases, it might happen that the error message you receive is not very helpful, so Microsoft support can handle this. Then last but not least, let's talk about some common issues. I mentioned it several times right now, maybe on nearly every slide I have. Never forget about the format issue in Flow. So it was simply, when you have your Flow, it's running perfectly fine. You open it, you want to review something. At a certain point in time, it will simply kick out the OData type definition and you get an error. This sometimes is very easy to find when you see the flow validation on the upper hand right in the flow editor. You will see that it is marking there's an error inside. In this case, simply check that the OData type is in the correct format. Then, as I mentioned, you have the limit of 10 open operation sets per user. So in this case, from time to time, simply check the operation set in the Dynamics environment and verify if you have open elements. As I mentioned in a previous version of the API, it was not automatically handled. Right now it is handled automatically, so after a certain amount of time, open operation sets not executed will be abandoned automatically by the system, but maybe simply check it. It's very easy to have a bike deletion job, let it run every night, easy as that. Then also a very important handling is null value handling. So just imagine you have a call like, I don't know, create a bucket. And in the bucket, you need the project ID. Remember back, PSS create operation for creation of project bucket is an operation where we need an operation set, where the create of project is not required to use an operation set. So it might be possible that the creation of project simply failed due to, I don't know, SQL timeout in the background, solution publish, something like this. So you are calling the create of project bucket, give the reference to the project, but the reference is simply null, so you will receive an error message when you execute the operation. So just keep in mind for the null values. It is also similar, like good example would be when you create a project and you want to give a project description. Description is not a required field. So when you create the project, let's say out of a quote, and the quote do not have a description, and you want to call the PSS create project, you give the description field in the JSON, but the description from the quote is null. It will also provide some errors. So simply keep in mind to have a look for null values in your attributes. Then, as mentioned in the previous one, marked for the project task dependencies, it's important to think about it's case sensitive. And at a certain point of time, when you run your flow and you see an error message, very cryptic, like property value was found in the payload of blah, 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 this is highly the chance that you have a typo in the schema name. So simply check back what is the original schema name in case-sensitive format. And then again, some basic notes on the project operations API itself. You need the correct privileges to access all the data in the system. You also need to have a valid project operations license. And also check that the basic configuration of the environment is correct. Like you need the schedule parameters in the parameter settings and so on and so forth. And lastly, while it is a service outside of Dynamics, it is also maintained by Microsoft. There can be downtimes like maintenance. Every customer engagement administrator knows it. Microsoft runs the updates every Friday night over the weekend. So simply it's the same for the API. So there can be downtimes. But this you will then also see in the error logs. Okay, now I would say I'm in the Q&A session, so I will stop the presentation and switch over to my sample flows. Okay, this is a demo environment, so it is not out of the box, as you can see. And let's start with very basic flows. As I mentioned, right now we have an API supporting the handling of the project buckets.
Sorry, Daniel, for interrupting you. We have 15 minutes left. Yeah, I don't know how much time you need more.
I will be quick that I can have a Q&A.
Okay, perfect.
Okay, here was the basic idea when we create the project. It simply creates a default bucket, what is called bucket 1. So it's not very handy for a user. Just imagine you are using DevOps and you have a very nice board with all the different phases. So I just wanted, on every creation of a project, create my default set of project buckets like new, to do, in progress, done. So we see we have the initial trigger, a project is added. Keep in mind, this can be any trigger, like the user is creating the project, API is creating the project, or Flow is creating the project. It doesn't matter. I call the create operation set, as we see without trim operation, very basic. Then in the first step, I'm checking if there's a default project bucket already existing. So this would be bucket 1. And then simply as a condition, when we have no bucket, I want to create one. When we have the default bucket, I want to rename it. And for this, as we see, renaming, I'm using PSS update v1. And for the creation, I'm using PSS create v1. The handling is nearly the same. And again, you see, I created the flow already. The flow is working, but I'm missing one of my friends here. So keep in mind to always check back on this. So as we see, create a new bucket. Here I have my handling for the IDs. So this is the first ID. And here I'm using the ID of the original default bucket. Just to highlight, as I mentioned, I simply create a JSON file where I store all the different bucket GUIDs and also their names. So we stack all these together in the operation set. I have a new to-do bucket, my in-progress bucket, and lastly the done bucket. And then as mentioned, I have the abandon step. If something happens before, it simply cancels the operation. When all is fine, we have the execute. And as I mentioned, because it is an async operation, I put in my wait condition calling the get project save status. And for this, it's just important to note, keep in mind the default limit is 60. So just adjust this one. And as mentioned above, you see here the flow checker giving me some alert like data is not correct. And here you see CY. It is in create new bucket. I clicked in this formula and you see it's invalid. I'm missing one of my friends. Clicking out and the error is gone. So we see creating operation set, stacking data to it, execute it or cancel it, wait for the operation to be completed, and then perform next steps. And in this sample, I simply added an error message that you can see how it happens. So the first operation is completed. I get a schema validation error in my last message block, will abandon the operation, and all is fine. Okay, this was it. I would have more samples, but I think we are short on time. Yeah.
Thank you, Daniel. To be honest, there was not that much questions, and one was answered by Matthew. The question was, how do you assign resources using APIs and not manually as a resource manager? And the answer from Matthew was you could create resource assignment records. I don't know, do you have anything to add here?
I can simply maybe share this. I mean, as mentioned, I can add a project team member, and then I can also add a resource assignment. You see, I can add a new user with a role to the project. In this case, I'm using resource XYZ to the project team. And then I also have the operation where I create a resource assignment and assign this team member to a dedicated task. You see, I'm creating a task. In this case, we see it's level 2, level 2, level 2. And I'm assigning this user. At the end, this would look like this. So I created the project, I created the task, I added the project team member, and then I created a resource assignment, assigning a resource to this task. And just as I mentioned, the The estimates are distributed over these days. I use a duration of 6 hours, and we see it is over 2 days, so it's split at about the runtime of this task.
Mm-hmm.
I hope this helps answering the question.
Yeah. There is the other question, or yeah. Daniel, do you see the chat?
The last one, yes. Project template with 100 tasks. When using a project template, this I also mentioned at the very beginning, it is not necessarily required to use the API to create every task individually. You could do this, but it can create an error when you have resource assignments as well and dependencies as well, because you reach the limit of 100 operations inside one operation set. When you want to use it as a template, simply use the copy project functionality. It creates an exact one-to-one copy with every WBS element, also the project estimate lines. And with the start date, you can shift the project to the given start date. I would say it's easier and definitely faster. I can say copy project will not time out with 100 tasks. I was using it for a big structure already, and it is working perfectly fine. But also in regards to the API itself and performance, as I mentioned, the PSS safe status is very important, and Microsoft has a performance document, and they say stack as many operations inside the operation set. So when you have 500 operations, stack them up to 100 in every operation set, and do not create a single operation set for, let's say, 10 operations execute, 10 operations execute. So put as many operations inside as possible.
Okay. Yeah, thank you, Matthew, for your questions. I think we will stop somewhere here because it's already time. For the rest of you, I would suggest if there is any other questions, please contact Daniel directly or contact me directly in social media or our group. You'll easily find it in Facebook or LinkedIn. The recording, there was the other question about the recording, will be available on YouTube channel and our social media soon. So yeah, that's pretty much easy to find it, or just subscribe to our YouTube channel or our LinkedIn, and then you'll get the last updates and notifications. Thank you all for joining us today. It was a pleasure to have you here, Daniel, as well. Thank you for preparing this interesting content. And yeah, looking forward to see all of you on the next webinars, and have a great evening or day. Doesn't care whenever you are. Yeah, thank you so much, and see you next time. Bye.